Okay, now let's talk about our next counting method, which is permutations. So again, we're just talking about the ways to count the possible outcomes rather than listing them. So when we need to pick a group of items from a larger group of items without repetition, so maybe like we're picking 20 items and we can't repeat any of them, okay? We're going to need to use either permutations or combinations. Now, when do we use either one? Well, if the order in which you pick the objects matters, you're going to use permutations. Permutations, P, position, order matters. So permutations are used when you're arranging a group of items without repetition and order matters. Okay, same thing, just condensed into the proper definition, right? So here's the formula for permutations. It looks really intimidating, I know, but give me a second. I'm going to show you a shortcut on how to calculate permutations a little faster than some using this formula, at least in my opinion. So here's permutations. The big P here stands for, you guessed it, permutations. Okay, great. Now what are these other two numbers over here? Well, N is actually going to be replaced with the number for the size of the group you are picking from. So the group you are picking from. So like if you're running a play or something, you're a director and you have 20 people to choose from, okay, and you want to place maybe 5 of them. 20 would be the first number you have here because that's the size of your group, whereas the number to the right of the P is going to be the size of the group you are picking. So if you're picking 5 people to be in your production, you're going to write 5 next to the P. Now, this is n factorial all over n minus r factorial. I'm not going to use this formula. I'm going to show you a little shortcut on how to calculate permutations. So stick with me. We're going to run through some examples. So here's the basic way to calculate permutations to start off with. So here we have 7p3. So remember the first number here is the size of the group you are choosing from. So you have 7 people in front of you. And you need to choose 3 of them, okay? Now, this goes along with our play because we have different positions available. So maybe one is the lead actor, one's a supporting, and one's kind of like a stagehand or something. I don't know. I'm not in the field, but that's okay. You get the idea. Each position is different, so the order that you pick them matters, right? Okay, so placing one person in the lead is different than stagehand. So we're picking 3 people. We have 7 people to choose from. So how many positions do we have open? We have 3 positions, right? I told you maybe the first one was lead actor, second was supporting, the third one was stagehand. So how many options do we have for that first position, that lead actor role? Well, if you look at all the people you have to choose from, you have 7 people to choose from. So 7 options for that first one. Now, once you pick the lead actor, can they also be the supporting actor and the stagehand? Technically they could, but that'd be very difficult and you wouldn't want to do that, right? You want your play to be more than one character. So we have eliminated one option, so we have to decrease it by 1. So the next choice, we only have 6 options because we already picked one to go in that first place. Okay, so now we have our main actress, we have our supporting. Now the third one, stagehand. How many options do we have left? We only have 5 left over once we picked the first 2 positions. And then just like the multiplication rule, we're just going to multiply those together. So 7 times 6 times 5, 210, I believe. Let me double check though. 210, yes. So 210 different ways of placing 7 people into 3 positions when your order matters. Let's go ahead and try it again. So 15P4. So 15 people to choose from this time. Got a better turnout. Thank you. Okay. We got a better turnout this time. So 15 people I have to choose from. And I need 4 positions this time. Maybe there's a second lead supporting actor role or something. So we have 4 positions that we need to place. So 1, 2, 3, 4. Now, how many choices do we have for that first position, that lead actress role? Well, we now have 15 people to choose from. And again, every time we go to the next position, we're down 1, right? We're down 1. So you keep doing it, 13, 12. So each time you're decreasing by 1 because you're taking one of those options away. Once we have all those, we just need to go ahead and multiply together. So 32,760. Wow, that really jumped up, right? Because now we have 4 positions and we have 15 people to choose from. So there's like 32,760 different ways to place those people. Crazy, right? Okay. Lots of different ways. Okay. Now let's go ahead and do a word problem and explore why is this a permutation, because that's going to be important to keep asking yourselves, is this a permutation or combination? So we need to explore why is it. So there are 8 students running in a race, and the top 3 winners receive medals for first, second, and third places. A gold, a silver, and bronze. So each place is different, right? So as long as each place you're giving is different, just like the lead actors, the supporting, and then the stagehand, those are all different, right? Different roles. We are going to use permutations because the order matters. How many different ways can the race be won? So this is permutations, as we said. Order is going to matter. They're different positions. Now, the number to the left is how many people we have to choose from. So tell me, how many people do we have to choose from here? Well, it looks like we have 8 students running. So that's how many people we have to choose from. But the number on the right is how many places we have. So how many places do we have to choose from? Well, looks like we're only giving 3 places. Sorry, participation awards are not going to be granted this time. So let's go ahead and list the 3. So we have 3 spots. How many spots do we have? How many people are up for that first position, first place? 8. Then once you choose the first place, then you have 7. Then you have 6 for third place. Remember, it's just 1 less each time. Multiply it together, and you get 336 different outcomes. 336 different ways. There's not really that many students, and there's so many different ways you can do a combo. Because remember, first place is different than second place, right? At least that's what your kid says when they come home crying because they didn't get first place. Tear? Okay. Hopefully not. Hopefully they're good winners or losers, right? Okay. Let's do our last example. You buy a lock which has a dial with 50 numbers printed on it. A lock is opened by dialing 3 different numbers in a certain order. How many sequences are possible? Okay. So we probably have all had locks, especially in high school when you were unlocking your locker, blah, blah. So why is this a permutation? You need to ask yourself that, right? Is it permutation or combination? Well, you're doing different numbers, so you're not repeating anything. That indicates it's either permutation or combination. No repetition, okay? Just like the last one, you couldn't get first place and second place. Not possible, okay? So this one, different numbers. You can't repeat anything. But the key here on why it's a permutation is that there's a certain order. Whenever position matters, we have to do permutations. So permutations, the number on the left is how many numbers we have to choose from. Well, it looks like we have 15 numbers to choose from. And then how many numbers are we picking though? Well, we only have 3 slots that we need to fill. So let's go ahead and calculate that. So again, there's 3 slots we need to fill. 1, 2, 3. How many slots options do we have for that first number? Well, looks like we have 50 numbers to choose from. But once we choose that number, we can't use it again, right? It has to be a different number. So we need to reduce it by 1. And then just multiply across. So 50 times 49 times 48, this is going to be a big number. 117,600 different ways. That is a lot of ways, or a lot of sequences that you could have, even when you can't repeat numbers. If you could repeat numbers, it'd be a lot more, but we can't, so it's only 117,600. I would not want to try and guess all those different combinations. That'd be terrible. All those different permutations, I should say. Because order matters, right? When you're on the lock, trust me, it definitely matters. Okay, so that was our set on permutations. Now I want you to go ahead and watch the video on combinations, where we'll talk about when order doesn't matter. Okay, so that's going to be our next one. Check it out.